Hi, ladies and gentlemen. So here we are on page 132, and we're going to work through this one. And so it's example 4. We have an isotope called strontium, and it has a great symbol, doesn't it? SR90. Now, this is not mathematical. This is a name. It's a chemical name. Don't get confused. And this, what is it? It's an isotope of strontium. And it has a half-life of 25A. Now that's short form for annum, which is Latin, annum, I think that's right, which is Latin. Why do I spell things? I know I can't spell. Latin for year. Okay, so that's what the A stands for. So again, find the mass of strontium, that's a name, remaining from a sample that's 18 milligrams to start. Let's zoom in here a bit. 18 milligrams to start after 125 years. That's cool. Let's come up with a formula. Notice that they say half-life. That means that my base is going to be a half. Okay? So for half-life, we use M, and I think I want to use M of T, where my function is T, the number of years, and it's going to equal my initial amount, C, and I'm going to multiply it by 1/2 because it's half-life, and it's going to be the amount of time that goes by divided by the half-life time that it takes. Filling in what I need to fill in, I'm going to have my initial amount is 18 milligrams. That's what I'm starting with. The amount of time that goes by is 125 years, and the half-life is 25 years. So, we got a couple of things to look at here. Filling in what I need to, it's going to be 18, 1/2, 125 divided by 25. So the number of half-life periods is going to be whatever this works out to, and that works out to 5. So there's going to be 5 times when this 18 gets subdivided in half, then subdivided in half, then subdivided in half, then subdivided in half. On and on and on it goes. So it's going to, I'm not sure why I rewrote it, but I did. Wasn't that nice? Using your calculator, I'm going to do 0.5 to the exponent 5 equals, if you don't do equals, you're going to make a mistake. I'm just warning you. Times 18, hit equals, and this is how much we've got left, not a whole bunch. That's the answer. That's it. That's what you got left. All right, B, how long will it take? That's a different question. How long will it take for the sample to decay to this much? Well, your initial formula, again, is going to be M of T, where T is how many years they give you. It's going to be our initial amount. It's 1/2 because it's half-life, and it's T over H. Now, we can do better than that because we know from the example above that our initial amount is 18 milligrams. We can do better than this. We know that its half-life time is 25 years. We can do better than this. They want it to decay to 9/4 milligrams. Now, they're working in fractions for a reason. I wouldn't put that as a decimal, guys. Let's fill it. And what are they looking for? They're looking for how long is it going to take to do that. So let's fill in what we got. We've got 18. Oh, the 18 doesn't go there. My mistake. You've got 9/4 equals 18, 1/2 T over 25. Remember that your variable is up here in the exponent. So what we need to do is be able to get, we need this. This is your concept. We want okay? That's what we want. That's our concept. That's how you solve exponential equations. So this 18 here. Do not take 18 and divide by 2 and get 9. Do not. That's not what this means. We got to divide both sides by 18 at the very beginning. So it's going to be 9/4 divided by 18. Notice how I'm writing it just to make it nice. And this is going to be 1/2, still t over 25, with that still up in the exponent. Now what this means is 9 over 4 times 1 over 18. Now notice I wrote it that way for a reason. You could use your calculators, but I'm going to be able to reduce here. So this is a 9 on top, and this is an 18 on bottom, so that's going to reduce. 4 times 2 is going to be 1 over 8 equals 1/2 t over 25. It's better. 1/8 is not the same as 1/2. They're not the same basis. But if I think about things for a minute, if I change this to base 2, because you know that 2 to the 3 is 8, so I looked after that 8 part, and you should be able to, after the work that we've done, see fairly quickly that that is an equivalent statement. So 1 over 2 to the 3, I can take the 3 on the outside, so it would be 1 to the 3, which is just 1, and 2 to the 3, which is 8. So I get all the way back to here. Now to be honest with you, I'd like you to go from here to there directly. This is what I'm thinking in my head, but I'd like you to be able to do that directly. Notice what you've got. Your bases now are the same. That base and that base are the same. So, and we've got an equality here, which means, therefore, 3 equals t over 25. What that means is we can bring that up. We're going to multiply both sides by 25. You're going to get 75 equals t. So therefore, it takes 75 years for 18 milligrams of SR90 to decay to 9 over 4 milligrams. And notice if you had changed that 9 over 4 to a decimal back there, now let's zoom out a little bit. If you had changed this 9 over 4 to a decimal, whole thing would fall apart. You'd be making a mess all over the place. You'd be getting a decimal. So you would have done 9 divided by 4 equals, you would have divided that by 18, and you would have been left with, not that it's impossible, don't get me wrong, but you would have been left with this. Now that's certainly not impossible. What you would do then is change this to a fraction. I'm going to divide the top by 25, so it's going to be 1, 2, 3, 4, 5. Dividing the bottom by 25 is 10. Is 1,000 divided by 25, so that's 40. T over 25. 5 over 40 is simply 1 over 8. And then you get back to where we were, which is fine. I'm okay with it. Just make sure that you're going to be able to do that if you do switch that to a decimal, okay? So that finishes off 132. So what does that leave for your homework? I think I'm just going to throw the whole thing at you, and we'll talk about it when you come back. So you can do 1 to 4. 1 to 12. And your answers are up here, guys. So give it a shot, do the whole thing, and we'll take it up when we see each other on Monday. All right, guys, I'm moving on from here on Monday once we take it up, though. Bye-bye. Have a good weekend.